Welcome back to ME 760 Engineering Analysis 1. So today we will start a new topic about differential equation, and hopefully this will be the last topic for the ME 760 until the end of the semester. So today, before just starting the topic, we want to give you some taxonomy about the differential equation, how we will for example, recognize that this is a differential equation, what degree of differential equation, what order, and so on. Is it linear or nonlinear? So we have to give some taxonomy about the differential equation. So let's start. So this is differential equations. So today's lecture is a little bit more wordy, so there is lots of wording that we will write, minimum of, let's say, examples, but at least once you get the definitions and you memorize it, I do not want you to memorize it literally, but at least you know what's going on so that you will be able to differentiate. From now on, I think it will be easy for you guys to figure out what type of differential equation and so on. So before we start, if we say we have a function y of x, for example, this x, usually we call it or name it the independent variables, because it does not depend on anything. I can give it an initial value, and then y will depend on the value of x, and this is the function, the definition of function. So y is called what? Dependent variable. And all of you know this from Calc 1. So I will give you a bunch of differential equations. Then we will give the definition for differential equations and see which one of those will fall into this category of definition, for example. So we will have dy by dx plus 5y is equal to sine x. We will have the well-known formula for radioactive decay, dn by dt is equal to negative lambda n. We will have xy prime plus x sine y is equal to 0. And we will have dz by dx plus dz by dy is equal to y squared plus x squared, plus yz. And we will have, let me write 5 here, y double prime cube plus y prime square plus 3y equal to x squared. Number 6 is dy by dx to the power of 3 halves plus xy equal to 0. If you just square, if you take this to the other side, it will be negative xy. If you square both sides, this will give you dy by dx, which is y prime. I can write it as y prime cube equal to x square y square. And number 7 is nabla square f of x, y, and z is equal to 3x y z. And finally, number 8 is y triple prime plus 2y prime plus y equal to 0. So triple prime means what? Third derivative. Okay. So here is the definitions now. So ODE means ordinary differential equation. So ODE, ordinary differential equation. So we will have only single independent variable in the equation. So we do not allow more than one independent variable like x, for example. So which one of those will have ODE? 1 is ODE, 2 is ODE, because I have only what? I'm differentiating with respect to x, which is the independent variables, and this is x, t, so 1 and 2, and what? 3, this one? Oh, okay. So 1, 2, 3, and what? 5, 6, no, 8. So we said what? 1, 2, 3, 5, 6, and 8. So partial differential equation that we have more than one independent variable. So which one do you think? Number 4 and what? 4 and 7. Okay, the degree of the differential equation. So the degree of the differential equation is defined as the degree of the highest order derivative. So we'll look at the highest order derivative in each of the equation and see what degree. Is it raised to the power of 1 or 2 or 3 or 4 and so on. Okay guys? Derivative after the rationalization. What do we mean by rationalization? Like here. So this is a ratio, 3/2. Okay? So we have to rationalize this one first. So we'll raise it to the power of what? Square this and square this so that you will make it as integer, not a fraction. So you have to rationalize your differential equation, then look for the degree. Okay guys? So first degree, what equation? 1, 2, 3, and 4. So 1 to 4, and what else? 6? Nope. Nope. The highest derivative is y prime, and it is raised to the power of 3. So it's not first degree, it's third degree. So you look at the highest derivative. What's the highest derivative? There is only one derivative, y prime. Then I look at what? I look at the degree of this first derivative, which is what? 3. Yes? You do not understand.
It's still first derivative.
Yeah, but I am looking for the degree. So degree of the highest order derivative. What's the highest order derivative? So if you have y square to the power 2 plus y double cube to the power of 4 plus y to the power of 6, what's the degree? Nope. The degree is 4. Why? Which one is the highest? Is the highest order derivative? This is not a derivative. This is second order derivative. This is third order derivative. So we will look at the third order derivative. It raised to power of what? 4. So this is the degree of the differential equation. Did you understand, guys? It's not 6. It's the derivative, the highest order derivative. What's the degree of the highest order derivative? Did you understand? Okay, so 1 to 4 and 6 is not included. And then we have what? 8. So second order or second degree, sorry. None. Third degree. What? What else? 6. So 6 is raised to the third. The first derivative is raised to the third, and the second one is what? Number 6. We said what? 5 and 6? Yes. 5 is 5 to the third, and also 6 to the third. Yes? Did you have any question? Yes, go ahead.
Does equation 7 apply to any of those first, second, or third degree?
Okay, so this will be the function, whatever function you have, but this is partial differential equation. So let's assume that this will be df squared by dx squared. This is order the highest derivative is the second derivative. So this is d2f by dy squared plus d2f by dz squared equal to 3xyz. What's the highest derivative? This is the partial differential equation. All of those are what? What? So this is a second order, yes, because it is second derivative. And what's the degree of each one of those? First. So it is first degree.
So you should add it in the first degree.
First degree 7.
Yeah, but this is partial differential equation. I can say to where number 7 and 8. Yes, number 7 here. All right. Okay, guys. Now we define the degree. So now we can define the order. So what do you think what the order will be? Huh? Order. So order is what? Order of the highest what? So first order. Which one is first order? I took off the. You can look at your notes.
1, 2.
Okay, 1, 2, 3, 4, and 6. Second order. 5 and what? 5 and 7. And third order is what? 8. Did you get it? So the order is look for the highest derivative. This is the order. And degree is look for the highest derivative, the order of the highest derivative, the degree of the first derivative, the power of the highest derivative is the degree. Okay, guys? Okay? So this is, let's write it like this. Y triple prime to the power of 3 plus 5y double prime to the power of 6 plus 7y prime to the power of 8 plus 8y equal to 0. What's the order? Order is what? 3, because it is the third order. Yes? Third differential. What's the degree? Because the highest derivative has raised to the power of what? 3. So this is order 3 and degree 3. Don't be deceived by this or this. Okay, guys? Did you understand? So now we will look for the definition of linearity and nonlinearity. So if it is linear, what do we mean by linear differential equation? It's every term in the differential equation has dependent variable to first or zeroth order power, sorry, zeroth power. So what's in the equation we have? What does it mean? Linear. So if I have y, let's say y double prime plus y prime plus y equal to 5, this is a linear equation. Okay, guys? If this is y double prime plus y prime square, it's nonlinear. Why? Because any of the dependent variables should not be of power more than 0 or 1. Okay, guys? This is raised to the power of what? 2. So if this is like this, linear or nonlinear? Nonlinear. Again, the dependent variable y is raised to a power greater than 1. Linear or nonlinear? Nonlinear, because if you rationalize this, you will end up with what? With squares on the others. Okay, guys? So then don't be deceived by, oh, this is less than 1, so it's still linear. Okay, guys? So nonlinear. So what are those for the linear? 1 and 2, 4, 7 and 8. So nonlinear. The dependent variable will be raised to power not equal to 1 or 0, or we will have a non-algebraic function, non-algebraic function. So if you look at this, you will notice that 3, 5, and 6, all of them are what? Nonlinear.
What would you consider a non-algebraic function? What do you mean by non-algebraic?
Okay, so I will give you the example here. This is x, y prime plus x sine of y equal to 0. So the independent variable, although it has a power of what? A power of 1, but it's not a separate independent variable. It is inside a nonlinear function, and the sine is a nonlinear function. If you plot this sine y, is it a linear function like this, or is it a nonlinear function like this? Okay, so any nonlinear functions, you have it for the independent variables. This is now is a nonlinear equation. Okay, so if you have, although here the highest derivative here is y1, which is just the first derivative, yes, but it is raised to the power of 1, and this is raised to the power of 1, but one of the independent variables here in the equation is not in a simple form. Is not let's say ay plus c. Yes, so in this case it's a functional form that's nonlinear. So this is a nonlinear equation. Yes.
So there's nothing to do with the independent variable.
No, the independent variables. If you have independent variables, like if we have this equation, let's assume that this is the equation, exactly the same, plus xy instead of sine y is equal to sine x. So what's this? Linear equation. Okay? It's a linear equation. Why? Because all the independent variables are raised to the power of what? 0 or 1. But the independent variables, this is called differential equation, ordinary differential equation. It's a linear, so we call it linear ordinary differential equation with variable coefficient, because the coefficient is not constant. It's variable. And no matter what you have here, if this is equal to 0, we will see in a minute that this is called homogeneous differential equation. Because I have a term here that's not 0, this is called inhomogeneous equation. But let's say I have this as this. So what's this? It's nonlinear, because the independent variable now appear on a functional form that's not a linear function. Okay, guys? I know that the taxonomy, it's a little bit tough at the very early beginning, but once you start solving lots of differential equation, and we will see this, we will know how to solve each one separately, okay? And the most difficult one to solve is the nonlinear differential equations. Okay, guys? So I already defined the homogeneous, and I will define the inhomogeneous also equation. So homogeneous equations, homogeneous equations are those equations that each term contain the dependent variable, or one of its derivative. So if you have all the equation, each term has the dependent variable y or its derivative, y1, y2, y3, and there is no constants in the equation at all. So this is called what? Homogeneous equation. So let's say a y double prime plus b y prime plus cy equal to 0. So this is what? Homogeneous equation. In homogeneous equation, we will have, it will has terms without dependent variables or its derivative. Like what? Like exactly the same, ay double prime plus by prime plus cy plus d equal to 0. So this is homogeneous or inhomogeneous? Somebody will say, oh, this is homogeneous, it's equal to 0. I say, wait, this is inhomogeneous because I have a term here that does not have y or y prime or y double prime or y triple prime or blah blah blah. So I can bring this term here as negative what? Negative d. So a y double prime plus b y prime plus c prime cy equal to what? Equal to negative d. So it's no longer homogeneous as you think. So what equations are homogeneous? 2, 3, 6, and 8. And for this one will be what? 1, 4, 5, and 7. Now we looked at the taxonomy of defining the differential equations. Now let's look for their solutions. So usually the solution will be in two different forms. One is called explicit. What do we mean by explicit? that you can separate y of x from what? From all the x's. So this will be y of x equal to what? Certain function of x. Y of x equal to 3x e to the power of x sine cosine x, something like this. Some strange function of x. So as long as you separate y in a left hand side and the rest of the x's in the right hand side, this is called explicit. Okay guys? The other form is what? Implicit. And this will be just a function g of x y equal to 0. To take an example, you know all of us love examples. So if we have dy by dx plus 3 over 2y over x is equal to 0. How to solve this one? dy over x by dx equal to negative 3 over 2 y of what? Y over x, and this is called separation of variable. So we will do what? We will do dy and we will divide it by what? By y equal to negative 3 over 2 dx, and it is divided by what? X, and this will give me what? Ln y equal to what? Negative 3 halves multiplied by ln y. Ln what? Ln x plus what? Ln some constant c. Yes? If you say, oh, plus constant, I said, okay, I will put the constant as ln c. Ln constant is a constant. Okay, guys? So, now I can bring this one up here. So it will be x to the power of minus 3 halves. So this will be ln y equal to ln x to the power of minus 3 what? Halves. And if we have ln something plus ln something, is the ln of the multiplication of the two things. So this will be the ln of c x to the power of minus what? 3 halves. And this will yield what? Y equal to what? This will give me what?
Y equals exponential x.
Y equal to what? It's not equal to exponential. Ln of y equal to ln of this. So y equal to c multiplied by x to the power of what? 3 halves, which is c multiplied by what? X squared. Yes? So this is explicit or implicit? Explicit. How we will make it implicit? Just right now we will do what? Square this. So this will give you what? Y square equal to what? C square over what? X cube. And y square x what? So we'll make negative equal to 0. So this is what? This is explicit. And this is what? Explicit and implicit. Okay guys? Do you have a question? Okay. So let's look for the properties of the solutions. First property. Point 1. An ODE, or ordinary differential equation, will generally has an infinity of solutions. Infinity of what? Of solutions. This is the first property. infinity of solutions. So we'll give an example. dy by dx equal to alpha y. What's the solution? Y of x equal to some constant e to the power of alpha what? X. If you plot this with x, you will notice that you will have something like this. This is for c greater than what? 0. And you will have something like this for c less than what? Okay, guys? So we have infinitely many solutions. It depends on the values of what? Alpha and c. Yes, alpha is the power of alpha. Second property is usually an ODE of nth what? Order. What does mean nth order? So the derivative is what derivative? What? Huh? What's the order of the differential equation we just stated? The highest derivative. Order is the highest derivative. So if the order of the differential equation is of nth order, so what's the derivative now? Nth derivative. Yes? So if you have yn plus ayn plus byn minus 1 plus cyn minus 2 plus blah blah blah. What's the order? N. So this is differential equation of order what? N. Is it linear or non-linear? What's the highest derivative? This one. It is raised to what power? 1. So this is what? Linear. So this is linear differential equation, yes, of order n. So this is nth order linear differential equation, and if those a, b, c are constants, we call it nth order linear differential equation with constant coefficient. If a, b, c is not constant coefficient and they are functions of the independent variable, which is x, so this will be a of x, b of x, c of x, d of x. This will be nth order linear differential equation with variable coefficients. Did you get it, guys? Did you get it? Nth order. Linear, because it's not non-linear. Differential equation with constant coefficient. If those are constants, or if a, b, c are function of x, it's nth order linear differential equation with variable coefficients. Did you get it? Okay, so if you have an equation like this with nth order, you will have how many solutions? N solution. So if you have a second order equation, you will have how many solutions? 2. If you have a third order, 3. If you have a fourth order, 4. It is exactly the same like the matrices. If we have a 2 by 2 matrix, how many eigenvalues? 2. 3 by 3, 3. 4 by 4, 5 by 5, 6 by 6, and so on. Yes? And we knew that they will be, if the matrices will have a distinct eigenvalues, those will compose what? Basis for solution. Yes, they are the basis for the linear vector space. So we will see here that if we have an nth order, we will have nth order. This will has a solution with n arbitrary constants. So let's see now. See an example here. So the example is d cube y by dx cube equal to 5. What order of this differential equation? Third order, because it is a third derivative. Does it have any other derivatives? No, third derivative. What degree? 1, first degree. So it is linear or non-linear? Linear, because of first degree. So yes, 0 degree or first degree, yes? So it's linear. So how to solve this one? You will integrate it 3 times. So this will give you y equal to what? 5 over what? Over 6 x cubed plus what? Plus 9 x squared plus c2 or c1. c1 x squared plus c2x plus c what? c3. So how many constants here?
3.
Okay, guys. So if you have a third order first degree differential equation, you will have 3 arbitrary what?
Constant.
3 arbitrary constants. And this is not always true. And if you reparameterizing, if you reparameterizing, this can collapse. If you reparameterize the equation here, this can collapse the number of constants slash parameters. We'll see this later. So a solution of the nth order equation with n arbitrary constants is usually called a general solution. A general solution or primitive solution. And for a specific choice, of the constants, we will get particular solution. We will get particular solution. Show you an example here. Let's give the second point. This is number what? 3. So this is choice. I'm sorry. So to give you a number 4, a solution not tenable from the primitive is called a singular solution. A singular solution. And I will give you the example here. Then we will conclude and we'll continue next time. If you have an equation of the form 2 dy by dx all square plus x dy by dx equal to y. What degree? Second degree, so it's nonlinear equation. What order? First order. I have a first order here, and I have a first order here, but this first order is raised to what? So, nonlinear, yes, ordinary differential equation with variable coefficient. Why? This is constant, but this is what? X. Yes, it's a function of the independent variable, which is a linear function. So, the primitive solution, we just stated that in number 4, a solution of the nth order equation with n arbitrary constant is called a general or primitive solution. So the primitive solution will be just y of x equal to cx plus 2c squared. And you can try to see if this is the right solution or not. Okay guys, how you will do it? Just you will substitute here for this y here and see if the equation valid or not. Yes, so let's substitute. What's dy by dx? C multiplied by 1, and this is 0. So it's c. So c squared, 2c squared plus x. What's dy by dx? C is equal to y. So we propose the solution y of x equal to cx plus 2c squared. We substituted here, and we got what? Y equal to what? Cx plus 2c squared. So it is indeed a solution for the equation. Yes, guys? Now, let's plot this. So what's the solution? What do you think the solution? Is it linear? What function? Y equal to cx plus 2c squared. What's this function? What? A line. But because I have a constant c, can be any arbitrary constant, so you will notice that those lines are like this. Okay, guys? Okay? So all those lines are what? Cx plus what? But C1, C2x plus what? 2c square 2, 3, and so on. Okay, guys? So, and this span here, for this, we call it the line of family y equal to cx plus 2c squared. Okay, guys? This surface here that is enveloped to all those lines, this envelope here, the equation of this is what? A parabola. And the equation for this parabola, this envelope, the equation for the parabola is just x squared plus 8y is equal to 0. So what's y from here? Y would be what? Negative 1/8 x squared for this parabola. Yes? did this equation is a solution of this equation or not? We will do the same. If we want to know this is a solution or not, we will go and what? Substitute. So what's dy by dx? Equal to negative 1/4 x. Substitute in your equation. So 2 negative 1/4 x to the power of square plus x negative 1/4 multiplied by what? Negative 1/4 multiplied by x. Yes? Am I right or I did something wrong? Yeah. Equal to y. So this is what? 1 over 16 square multiplied by 2. So this is what? 1 over 8 is x squared minus 1 over 4 x squared equal to y. And this will give you what? This is negative 1/4 x squared equal to what? Equal to y. So 1 over 8. 1 over 8. So is it solution or not?
Yes.
Yes, it's a solution. Did we bring this solution from the primitive solution? No. We did not deduce this solution from the primitive solution. So this is why we call this singular what? Solution. Okay, guys? Singular solution. Okay? And usually the second property after this is we cannot have a singular solution for linear ordinary differential equation. This equation was what? Non-linear. For linear, we do not have any singular solution. But not all non-linear differential equation will have a singular what? Single solution. So we will stop here and continue next time. You have questions so far? Okay, thank you.